My name is Valentin. I work in the ESG office and the office of the CTO, but my background is performance. I actually had my first talk at VMworld 2011, and I talked about power management. And at the beginning, I told everyone, for optimal performance, you need to disable all power management features, because no one in the room has ever seen a power bill, and we all laughed. I am not making that joke ever again. Because now everyone in IT is painfully aware of the energy cost, at least for the last 2 years. So, as Thibault already said, the amount of power you can save using host power management varies. In their environment, they've seen 9 to 15%, which is quite respectable. In other environments, I've had a couple of projects with customers that have regular European country office hour VDI environments, but they're not quite ready to shut down these hosts using DPM, and they're saving up to 20% of energy by using host power management because, well, VDI machines are usually only running during business hours for that customer. But I've also worked with different type of customers. HCI environments, so highly integrated vSAN, NSX, highly utilized, and even in some telco environments where we're making progress in optimizing power management, well, we saw 4%. Now that might seem small, but if you're looking at a scale of multiple thousand hosts, that can be a lot. But I'd argue even if you're in a small environment, even small savings are worth it because it's so simple to implement. Now, this chart looks a little bit complicated. I want you to ignore the staircase. Just look at the graph and the right side. On the bottom, you see the CPU utilization on the x-axis. On the right y-axis, you see the power that is saved when you compare a high performance and a balanced policy. And as Thibault already said, they have not seen any performance impact, but I will get to that in a second. The point is, when you're using host power management, the more underutilized your resources are, the more power you can save. Now, this is CPU utilization. It's actually more closely related to the number of wake-ups. But at complete idle, you can save 30, and in some cases 40%, but for this particular set of hardware, 30. If you're running at 20% utilization, you can still save up to 10%. So what I'm trying to say here is if you're running your hardware highly utilized at 90% plus, host power management won't do much for you during normal operations. But even then, your hosts are probably not utilized at all times. Sometimes during the day, they will be less utilized. Now, let's talk about risk. As Thibault said, this was super simple to implement, and nothing is ever super simple. I have spent months in meetings about the discussion of risk and power management and performance, and usually what you when you group a risk factor and the benefit factor into a simple Gardner quadrant, right? If you have high risk, little benefit, you're not going forward with it. If you have high benefit and little risk, you would. I'd argue that host power management falls so little or falls so small in the risk part that there is no reason why you wouldn't proceed in implementing host power management. Has anyone here heard of power management? Has someone here performance as their main criteria? And of course, business operations or business continuity is a lot more important than efficiency, right, on the scale of risk. But power management really is not about power efficiency or performance, but you can achieve both at the same time. So it's not either or, you can have both. Is it operationally complex to change? It depends. How well do you interact with your hardware team or with the team that is responsible for BIOS configuration of your servers? Good relationship, you do it yourself, pretty straightforward. So I'd argue it is not that hard to change policies. Do you think you can only control it using hardware level controls, that you have to power cycle your systems if you have to decide between power efficiency and performance? No. All of that can be done at the API level whenever you want to retain full 100% control. And is it complicated? If you ask me, I've done this for 10 years, it's not. But there are some concepts that are involved that might require a little bit of soaking in. But I hope we can cover the most important ones here to your satisfaction. The main requirements that I'd argue we'd have to have is the impact. You don't want any impact, or maybe not any, but the least possible impact by default while still having some sort of efficiency semblance. But the most important part, I would argue, as someone who just yesterday wore an extreme performance t-shirt, you need full control. If there is any reason why you need maximum performance, no power efficiency, you should be able to do that within a second. Whether that's a break glass mechanism or whether there are applications that are more sensitive during certain parts of the day. It's critical that you do not sacrifice performance and business objectives. And the way how we went on implementing HPM, or how we implement HPM at pretty much any customer, is that first we go into discovery. In, I'd say, 99% of the customers I worked with, the host power management configuration is not the same across environments, across hosts. Hardware is managed by different teams and parts. So the discovery process, and by the way, on the bottom there are VMware short links. This is a PowerShell or PowerCLI script that I wrote that just grabs the information, the technologies that are visible by the ESXi host, and that makes it easy to compare the assumption of configured policies based on a couple of key criteria. You need to figure out where you're at and where you want to start. Now, the ESXi policy, we'll talk about that a little bit more, but the default is balanced. Now, balance doesn't do much if the BIOS is not configured properly, but you want to make sure that balance is configured if you want to do effective post-power management. When you configure your hardware, I would usually start within a cluster. Depending on your risk, let's say, sensitivity, I would just go with a full cluster by yourself. But there is no problem whatsoever on just configuring half a cluster. So you always have the opportunity to use either vMotion to double check for performance. But my argument here is that you should never have to do that. Switching between the ESXi policy, balanced and high, will give you 100% of your performance back if you follow these few simple steps that we go to in a second. And scale, scale slowly. I have to say that. I would obviously recommend you that you just do all of the changes in the, right at the start. But scale by hardware type, because the largest, I think my phone is just going off, but you can't hear it, great. And start with def, of course. And beyond what we're trying to explain here, if you're using a balance policy, you can create a policy where ESXi is even more power efficient. And you can run these at different times of the day. For example, you have the balance policy with no performance impact, but if you don't mind that there's a performance impact later in the day, you can just put it to a low or lower performance policy and save even more energy. Also, if you have different control levels for different types of servers and you want to save more power, you can do that too. Now, people ask, so how should I configure my BIOS? Is there a one-size-fits-all policy? And I want to say there is, or at least as close as we can possibly get while still avoiding the risk that we talked about. And if you take one picture, that is the link where I've written how to do that, just in case I don't get through it in the next 10 minutes, but I will. So I call this no-risk host power management. The more accurate term would be low to no-risk power management, but that doesn't quite sound as nice. The key aspect here really is the same across any hardware type, any vendor. Whatever power management policy gives you best performance, whether it's called max performance, low latency, full determinism, no matter what it's called, you use that as the base, as your baseline. You set it to a custom policy, retaining all of the same settings, and then you give ESXi control over the features it can control. None of the features it can't, because then you don't retain full control. The process is the same for every vendor. And I've outlined it for 4 of the big ones in the block, but I'll add more as I come across them. Now, how does this work? BIOS power policy is usually a number of options and a number of values for these options, right? The difference between policies is different values for these options. But you have power policies on both levels, hardware and ESXi. On the hardware, you have max performance, dynamic, low power, all kinds of policies. And at ESXi level, you have high, balanced, low, and of course custom. I'm leaving low out of here because balanced is just fine. Now, when you combine these different types of policies, you can have different outcomes. Now, it's not as simple as a straight line between maximum power efficiency and maximum performance. It's more complicated than that. There are some settings for some workloads where you have maximum power efficiency and maximum performance without any impact. But just for the sake of argument, let's just assume performance and efficiency are different sides of a spectrum. When you choose maximum performance, no matter what you do in ESXi, high, balanced, custom, you will always have maximum performance as the outcome. Because ESXi doesn't override the decisions of the BIOS. Right? We demark at that level. If you say maximum performance in the BIOS, ESXi is not touching anything. If you have a dynamic low power policy, you can actually control some of these features, but you will never have maximum performance. And many people run with dynamic power policies and wonder why from time to time they have inexplicit performance problems. Dynamic power management policies are a huge part in that. Yes, they're very power efficient, but they also risk performance. Now, you have more control doing that if you use an OS controlled policy in the BIOS. So the BIOS has different presets, and you can go give it to OS control. That might give you very good performance, but not necessarily maximum performance. But you still retain full control using ESXi. Now, what I'm proposing is if you really want to eliminate all possible risk factors with a custom policy, the main goal here should be that if you choose ESXi high, you should have the same as the maximum performance power policy, no risk involved. So you always have full control. And you should have, of course, the ability to control and use different settings, but you will never really achieve maximum performance efficiency. And I argue as a starting point, you should be performance conservative. You can always introduce more risk factors later on, but when you start out, you want to avoid as much as possible. Because imagine you're running an efficiency project, and all of a sudden, your ERP system has a 20% performance impact. That will be the last time you had an efficiency project with that particular feature set. So, how does this work? Well, the options in the BIOS are usually have different defaults. Performance defaults, efficiency defaults, or in some case, OS controllable defaults. When you choose a maximum performance power policy, all of these options will default to their maximum performance defaults. If you're using a dynamic low power policy, these options, for the most part, will default to efficient options. Some might be ESXi or OS controllable, and some might be somewhere in the middle ground. When you choose NOS controlled policies, and again, the name differ across vendors. Performance per what, performance what OS, right? The names are different, but let's just say OS controlled. You will have performance options or performance values. You will have OS controllable values, but you will also have some middle ground values, and there where it differs from the maximum performance policy. So again, the quite straightforward solution here is you configure everything to max performance with the exception of the settings that ESXi can control. And ESXi controllable might be different from Linux or Windows controllable because there are certain arguments about the demarcation of features, on-core frequency scaling, CBO link management. There are ways on overriding these, and we're continuously working with Intel and AMD to define the behavior. So we know when the BIOS defines something, whether we can override it if you choose to override it. Because again, in some companies, hardware and operations are siloed. So if the hardware team says we make a change, should you be allowed to override it? I say yes. I think that you should have complete control at the operating or even to some extent the application level. Okay, how do we do this? Straightforward, you read the blog, you follow the instructions, and you're good to go. Congratulations. Thank you for coming. Now, the script I mentioned before is straightforward. It runs against a vCenter, against a cluster, but it allows you to get a good overview over your environment. But please, you have to work well with your hardware team, whether you use Open Managed, whether you use Clarity, whether you use OneConnect. OneConnect? OneConfigure? OneConnect? Yeah, OneConnect, right? You need a good relationship with them because ultimately they're responsible. And while it is possible, and if they say it is possible to control power management using these tools, it is. But for 80% of the options, you need a host power cycle. And you do not want to power cycle your host just to change a power option. So getting the configuration rate is important. And again, you can start out using ESXi high performance, and there should be no difference whatsoever to the maximum performance power policy. Changing it over to balance then should give you the results that you intended. And if you need any help, talk to your account team, talk to your TAMs, they will talk to us. Or if you can guess our email addresses, feel free to email us as well. With that being said, we're at the end of our session with 4 minutes to spare. So if you have any questions. One question, of course.
For DPM, as you are stopping your host, did you check the number of times you can do it? Because the hardware has some limitation for the shutdown and power.
Sorry, I didn't.
I understand you, thanks to DPM, you shut down some of your host power.
Yes.
So as there is number of cycles for the power on the host, the PSU, you cannot switch them more than a certain number of.
So I think the question you're getting to at is, so the shutdown for DPM is an ACPI shutdown, meaning there's always power at the PDU and PSU level. You're very right that the PSU cannot be, because of current inrush, right, you can damage the capacitors, and most power PSUs have a limit of 1,000 to 2,000 cycles. Now, the same limitations do not apply to servers.
Because it's not a real shutdown. It's not powered on. It's still powered servers.
Yeah, so the PSU is still powered at the PDU level, but so you have 5 volts going to the switch, right? So some vendors do have supportability limits on the maximum amount of power cycles. It's called a full thermal cycle. So whether you do a power cycle like a warm reset, doesn't really matter. Most components can take at least low 10,000s EEPROMs, or the most sensitive components. But if you do a full thermal cycle, down to environmental temperature and back up, some vendors say there is a limit there. Now, some of the large ones do not, but do contact your vendor because there is a possible risk. I argue that that risk is minimal because we're talking data center temperatures. The temperature band for thermal equilibrium to go down and back up to operating is very small. It's not a robo environment in the back of a Humvee in the middle of a desert, right? So I think the risks are overblown for most vendors. And I talked to a large one that we used to work a lot more closer in the past, I'm not saying any names. They have said there is no limit on any of the power cycles. As long as you have warranty on your service, we will fix it if it breaks. So.
Okay, I think we're at the end of the hour, so we'll stay here. If you want to discuss, again, it's an important subject. So thanks, Valentin. Thanks, Thibaut, for sharing all of this. Please tell us what you think about this survey. Let us know through the application, because if this kind of topic is important for you, we need to know so that next year we'll be able to again do other sessions about this. So thanks a lot for your time and have a very good day.